video we will discuss how this binary tree is converted to a main heap, and also it can be converted to a max heap also. The property of the main heap, that means we are using this particular example, and if we check that 7 is a root node and which has less value than its children 10 and 25, so 7 satisfies to be the parent of the heap for this particular. But if we see that 10 has children 17 and 23, it is also less than of its children. Then 25 has children 27, 16, so 25 is not less than 16, so this is not a main heap. So this is only a binary tree. Now we will see how this binary tree is converted to a main heap. So what we will do, for this conversion, first we will start from, suppose it will be done through some iteration. Through some iteration, this binary tree will be converted to a heap, main heap. We will convert it to a main heap. So how this iteration will be done? So first of all, we have to find out the rightmost element in the tree. So which is 11? 11 is the rightmost element of the tree. So in iteration 1, what we will do, the tree is like this, that is 7, 10, 25, 17, 23, 27, 16, 19, 37, then 42, 4, 33, 11, 5, 33, 1, 5, 11. So the parent, this is a rightmost child, rightmost element in the binary tree. Now this will be compared with its parent. So what will be the parent of this node, which is 16. So we will start considering the operation from this node 16, which is the parent node of the rightmost element of the tree. So I will check whether this 16, if it is a parent, I will check whether 16 satisfies to be the parent of a heap or not. That means it will be checked if it satisfies to be the property of a main heap or not. What is the property of a main heap? The root node or the parent node will have the higher value than all of its children. So here 16 has value, will have the higher value than all of its children, then it will be a max heap. And when the parent node of every subtree in a tree is such that it has lower value than all of its children, then it will be a main heap. So we are constructing a main heap. So first in iteration 1, we will start from this parent. Now this parent is checked with its children 5 and 11. Now among these children, both are less than the parent node. So here the parent node should be swapped with one of its children, because children has lower value than the parent. So this could not be the parent and this cannot be the children for being a heap. So among these two nodes, which has the lowest value. Now this node has the lowest value. So 5 will go to position of 16 and 16 will come to position of 5. So after an iteration 1, what will be so the tree will be changed, because among these two children, the children which has a lower value, that will be swapped with the parent node if the parent node has higher value than its children, because we are constructing a main heap. So parent node cannot have the higher value than its children. So after conversion, the tree becomes like this: 7, 10, 25, 17, 23, 27. Now 16 goes to position 5 and 5 will come to the position of 16. So here it will be 5. Next, all other nodes does not change. Only those two nodes interchanges their position. Now this is, now the 16 comes at the place of 5. So it is 16 comes here and 11. Now we have to check 16 for further downward movement. If as the 16 has no child, if the 16, this new position of this parent node, if it is like that it has children which has lower value than of it, then it again swapping will be done. That means again the downward movements will be considered. But here the 16 has no children, so we will stop here. Then we will go to next iteration. Why next iteration? Because the parent position is not the root node. This node which this position of the node which we checked first as a parent, this position, this is not a root node. So we will go for next iteration, and in next iteration we will check the position for the previous parent, that is for 27. So we will go for next iteration, that is iteration 2, and in iteration 2 we will check the next parent of the of this tree. So if the tree I am writing once again 25, then 17, 23, 27, 5, 19, then 37, 42, 4, 33, 1, 16, 11. So now the parent will be checked for downward movement is 27. Now it will be compared with its children, which are 33 and 1. Now among them 33 is greater than 27, so we will not consider this child. But 1 has less value than 27. So we will interchange the position between 27 and 1. So the tree changes. It will be then 7, 10, 25, 17, 23. Now 1 will come to the place of 27. So here it will be 1, and all other nodes remaining same. Only the 1 and 27 will be interchanged with each other, and remaining all other nodes have no change. So the 27 will come to the place of 1.